present. I am going to share my screen. It is Thursday, March 2nd of 2023, and I want to make a couple of announcements to get us started, and then I'll see what questions you all may have. First of all, mini project number 2, which deals with confidence intervals, is due by Sunday, March the 5th of 2023 by 11:30 p.m. Also, next week, you will be taking your midterm exam. The midterm exam will open on Monday, March the 6th, 2023. It opens basically at midnight on Monday, March the 6th, and it will close on Sunday, March the 12th at 11:30 p.m. You do have to take it. It must be proctored via Respondus Lockdown Browser. That's why I had you do the Respondus Lockdown Browser quiz at the beginning of the semester. Excuse me, to make sure that your computer is compatible. If you've changed computers or had to get a new computer for whatever reason, if you need to ensure that your computer works with Respondus Lockdown Browser. Because we are using Respondus Lockdown Browser, you will not be able to access any other websites or even access Minitab during the exam. So I'll explain how we're going to get around that, because you do need Minitab for some of the problems. The midterm exam will cover all of the content from Module 1 and Module 2. You only have one attempt on the midterm. You may have one 8.5 by 11 sheet of paper with handwritten notes front and back. You can use what they call an approved calculator. You basically need one that'll do addition, subtraction, multiplication, division, and square root. Seems to be the other one that comes up in some of these formulas. You can get a TI 30 calculator at Walmart for between $13 and $20. You're not going to be allowed to use a calculator on your phone. You do have 120 minutes, 2 hours to take the midterm exam. You do, however, have to take it in one sitting, meaning that you cannot start, stop, start, stop. Once you start the exam, you have to take the entire exam. Okay, so you need to make sure that you allow for at least 2 hours of time when you get ready to take the test. If you take longer than 2 hours, the computer, D2L, Respondus, whatever, is not going to cut you off. Okay, I don't have it set to do that. What it will do is notify me that you took longer than 2 hours. It's not a big deal. Okay, so if you take longer than 2 hours, it's not a problem. I just get a notification. The exam itself is worth 150 points, and it does clearly state on the syllabus that any student who does not take the midterm exam will be assigned a grade of F unless you withdraw from the class, and there is no, makeup midterm exam. So please make sure you allow a 2-hour window, or at least a 2-hour window, for taking the midterm exam. To help you prepare for the midterm exam, I posted last week a review sheet and an answer key, and there's a video that works out the binomial, uniform and exponential distribution questions. So that document, I downloaded it or pulled it up on my computer. It has examples of the true-false questions you could see. It has examples of the fill-in-the-blank questions you could see. It shows you how the questions are formatted, since you're not allowed to access Minitab. the results from Minitab, for example, here on this page, in this that I just put a box around. Okay, let me kind of highlight it here. Is the Minitab output for the descriptive statistics. You simply have to interpret, read, analyze those results to answer, the given questions. Same thing with the binomial. For the binomial, I give you the table that we would have created in Minitab with each question. Now there's 3 questions here on the paper. I didn't copy it 3 times. Okay. But on the test, I have it with each question, and then you have to answer those questions. One of the things I would definitely tell you to put on your note sheet is the table related to binomial. Let's see if I've got a note about it. Let's see. Let me find that document. Okay, if you look at the midterm study guide, I remind you, okay, I even tell you things you may want to include on your cheat sheet. And you definitely want this table related to the binomial distribution that tells you how to calculate if you have a problem that has exactly, or at most, at least, fewer than, or more than. Okay, so you definitely want to have that. You'll need the formulas for calculating the mean and the standard deviation for the binomial and for the exponential. Okay, I've tried to give you and tell you everything that you might need. Then you have the uniform distribution. You have the exponential distribution, and then you have confidence intervals. Now, I would like to think that you took some time and looked at this review sheet. So if you did take some time to look at that review sheet, do you have questions specifically at this point related to the midterm that I can try to answer for you? There's only 3 of you in the room. You may unmute and speak, or if you need to, you can type it into the chat. Kaylee, I see you don't have any questions. Deidre, do you or Faze?
I do. I have a question. Will normal distribution be on there? Because I know in the video I watched, you said that it wouldn't because we've already taken that. I just want to double check.
I did not put any normal distribution questions on the midterm.
Okay, thank you.
Other questions? Okay. I'm not sure. I'll try to post it up tonight. I'm not sure if I posted this midterm study guide that has all those little notes about what you want to put on your note sheet. So I'll post that in the announcement for this week. So you'll have that. Okay. Tonight, I realize we have the midterm, but we also need to keep moving forward in the course content. But before we do that, do you have questions related to mini project 2, which is related to confidence intervals, before we get into the new content? Okay, the new content for tonight that we're going to pick up on according to our schedule is we're going to look at the hypothesis testing process, and then I'm going to introduce you to what are called parametric and non-parametric tests in a broad sort of way. This is the beginning of Module 3. Okay, so I did post the midterm review sheet that I've already referenced, but I also posted yesterday a set of fill in the blank notes related to hypothesis testing. Hypothesis testing really is something that we're going to utilize throughout the rest of the semester. It is one of probably the most important topics, most important concepts that we cover all semester. And it has a very specific set of steps. It's it's not necessarily a lockstep process, but the process is the same anytime you are doing a hypothesis test. And so I want to outline what those steps are first. And so that's what we're going to do tonight. And then next Thursday, we will come back and actually do it in an example format. I don't think I can get to all the way through in examples tonight. Now, this is a topic that is discussed in Stat 1401. So if you've had Elementary Statistics 1 recently, this may sound familiar. If it's been a while, hopefully it'll be a nice review for you, and some of it will at least sound familiar. So I hope you have these maybe pulled up on your computer, or you've printed them where you can kind of fill in the blanks as we go. And I'm going to add some explanations and things as we go. Typically, most research begins with a question. There's something that we want to know about. And so the first step in the statistical process is to state the question clearly with as much detail as possible, so that we can then do step 2, which is to identify the variable, the population, the parameter, the sample, and the statistic. And then we go out and collect the data, and we begin then to organize the data using the categorical frequency distributions or the grouped frequency distributions. We create the graphs and tables. We calculate the descriptive statistics. We may even calculate the confidence interval for one or more of the variables. But one of the steps that we often don't think about or don't do in that statistical process is when we pose that question. Maybe the question is, what is the most popular soft drink at GHC? Or what is the average age of a GHC student in spring 2023? What is the average height of elementary school kids? Or, whatever the question may be, when we pose that question, whatever it is we want to know about, at the same time that we pose that question, we probably have somewhere in the back of our mind an answer. So that answer, in terms of statistics, and it's also true in science, is our hypothesis. In science class, like chemistry, biology, physics, we call the hypothesis our educated guess, And you usually form that hypothesis at the beginning of your experiment. And so we also create or determine our hypothesis at the beginning of our statistical process. It's the educated guess, or in our case, it's the proposed answer to the research question. So we pose the question, and we may not verbalize it, but somewhere in the back of our minds, we have what we believe to be the proposed solution or the proposed answer to that research question. And then we collect the data and organize it and analyze it to try to determine if our hypothesis, our proposed answer, is right or wrong, valid or invalid, correct or incorrect. That process of determining whether or not our hypothesis is good or bad, valid or invalid, is called hypothesis testing. And we're going to talk through tonight, we're not actually going to do it, talk through those steps. So the first step in hypothesis testing is to state the two opposing hypotheses. There will always be two hypotheses. The first one is called the null hypothesis. The symbol for the null hypothesis is a capital H for hypothesis, and then we have a subscript of 0. You may or may not know, but the word null is an old English word for 0 or nothing, and so we use a subscript of 0. The null hypothesis is a claim about a population parameter that is assumed to be true throughout the entire process. It must always contain equal in some form. So if you think about hypothesis testing like a court case, if you relate it to the concept of a court case, when in the United States, when we conduct a trial, the defendant is considered innocent until proven guilty. And we make that assumption. We assume the defendant is innocent until proven guilty. We're going to assume the null hypothesis is true, accurate, valid, good, correct throughout the entire process. The parameter that we are going to focus on, there's a couple, but primarily for us, the population parameter that we're going to focus on will be the mean, primarily. We also talk about the median when we do non-parametric test, but usually the population parameter that we'll focus on will be the mean. It could be the standard deviation. It could be the variance. Okay, any population parameter. Now, you may not remember if it's been a while. The population parameter is one of the measurements associated with the population, and the population is the big picture. Okay, Now, the other statement here is that the population parameter should always contain equal in some form. So that means that when I'm looking at or trying to decide what my null hypothesis is, there are three options. Okay, it could contain equal, it could be less than or equal, but it might be greater than or equal. It has to be one of those three symbols. Which symbol you have is going to depend upon the phrasing, the wording of the scenario. So it's going to be very, very important that you carefully and purposefully read these scenarios. The second hypothesis, because there are two, and notice I said they are opposing. Okay, so the second hypothesis is called the alternative hypothesis. The symbol is the capital H with a lowercase a for alternative. It is also a claim about the same population parameter that is the exact opposite of the null. It will never contain equal in any form. One of those hypotheses will be given in the scenario. Okay, you are not necessarily, except maybe on some of the projects, going to come up with the hypothesis on your own. Okay, you're going to be given usually a paragraph, 3 to 4 sentences, and within those 3 to 4 sentences, you will be given either the null hypothesis or the alternative hypothesis. You have to decide which one you're given, again, based on the phrasing. I'm going to write them right up here underneath. For the alternative hypothesis, it says it will never contain equal, and it is the exact opposite of the null. So if the null is equal, the opposite would be not equal. If the null is less than or equal to, the alternative is greater than, the exact opposite. If the null is greater than or equal to, the exact opposite, which would be the alternative, is less than. Guys, they are always paired together that way. If the null is equal, the alternative is not equal. If the null is less than or equal, the alternative is greater than. If the null is greater than or equal to, the alternative is less than. They are always paired together in that form. And again, one of them is given to you in the scenario. If you were doing this, say, from scratch on your own, then you would come up with a hypothesis. And you could choose whichever one. You could say it was equal to something or less than or greater than, you could choose. In the problems that are set up in this course, you will be given either the null hypothesis or the alternative hypothesis. The alternative hypothesis also plays a second role. The second role it plays is it determines what type of test we have. What type of test you have is important because that is going to be one of the options, one of the choices you have to make in Minitab, because it affects the way the results are calculated. If we were doing it by hand, I would have to know what type test I have, again, because that affects the calculations that I need to do. So it's important that you know what type test you have, and that is determined by the sign in the alternative hypothesis. Okay, it also determines the type of test because you're going to look at the sign, whether you have not equal, less than, or greater than in the alternative hypothesis. And there are two options. Option number one is you have what is called a one-tail test. And it occurs if the alternative hypothesis contains either less than or greater than. And I'm going to try to show you why. Typically, when you're thinking about these tests, we are going to make the assumption that we have a normal distribution, which is our bell-shaped symmetric distribution with the mean in the middle. If I am trying to claim that something is less would be below or to the left of the mean, and I would be out here in the end of the curve. The fact that I'm at the end of the curve is what they call it the tail, because I'm at the end. I'm like at the tail of the dog or tail of the cat, tail of the horse. I'm at the end. And there's only one option. I'm less than. Now, sometimes to be more specific, they call this a left tail test because it is to the tail is on the left. It's only one tail because I have one option. It's less. But if you want to be more specific, again, they'll often call it a left tail. Similarly, with greater than, again, we make the assumption that we have that normal bell-shaped distribution. Our mean is in the middle, but if I have greater than numbers that are larger are going to be on the right side, and again, I would be in the end of the curve, hence the tail. But I'm on the right side because things that are greater are to the right. So again, you only have one option, so that's why it's called a one-tail, the one option being it's greater than. Again, more specifically, it could be called a right tail. The other option is you have a two-tail test. A two-tail test occurs if the alternative hypothesis contains not equal. Because the idea of being not equal allows for the fact that it could be less, but it might be more. You have to keep your options open because we don't know whether it's more or less. So visually, with a two-tail test, again, we often assume it's a normal distribution, our means in the middle, but with two-tail, we are assuming that it's not equal, not the same. So it might be less, but it could be more. And so I have two options because it could be less, which means you have this area on the left, or it could be more, so you have the area on the right. You have two options, hence two-tail. We're going to be using Minitab. In Minitab, the way you're going to make this decision is you're going to choose the appropriate sign in the alternative hypothesis. Minitab doesn't ask you, to say one tail, two tail, or left or right. Okay, Minitab is actually going to have you choose whether you have not equal, less than, or greater than. But if you go to a job somewhere and they're using a different statistical analysis tool like Excel or SAS or SPSS, you might be asked one tail, two tail, left or right. So just to be familiar with all that terminology. Okay, so step one is after you've read through the scenario that you're going to be given in the format for this class, you have to decide what is the null hypothesis and what is the alternative hypothesis. That is the first step every time. Then the second step is to collect the sample data and calculate the descriptive statistics. Okay, that would be the reality. If you were doing this research yourself, you've posed the question, you've proposed an answer, so you go out and you collect the data and you run the descriptive statistics like we learned how to do earlier in Module 1. Now, again, for the purposes of this course, we don't have time for you to go running around to collect the data. So you're going to be given the information, okay? So, and this is really what you're going to do, you're going to identify the given statistics or the given information. The information that you need or the information that you're going to be given is going to depend upon which hypothesis test is being conducted. And we're going to talk about a variety of hypothesis tests. Which one you conduct often depends on what kind of data you have, what you're trying to prove or disprove. And so it varies from problem to problem. And as we go throughout our discussions of each of the different types of hypothesis tests, I will tell you what information you need. Okay, I can't list all of them here. It would be a little bit confusing. So as we go, I will tell you for this test, you need these things. And again, for our purposes, all of that information is given in the problem, or you're given the raw data and can figure it out. So step 3, actually, I'm going to give you some of that information here. Step 3 is to determine which hypothesis test to conduct. And I only have some of them listed here. I don't have them all listed. We will initially talk about a one mean hypothesis test. And we have both a one mean Z and a one mean T. Okay, for a one mean Z test, we use it when we have quantitative data, which is our numbers. Our N, or our sample size, remember N is our sample size, is greater than or equal to 30. The population standard deviation is known or given. And this particular test relates back to the normal distribution that we discussed a week or so ago. If I am asked to conduct a one mean Z test, what do I need? I need the population mean, which is going to be the value in my hypothesis. The population standard deviation, which is sigma, should be given in the problem. The sample mean, which is X bar, should be given in the problem. The sample size, which is N, and the level of significance, which is abbreviated alpha. And we'll talk more about what the level of significance is in just a few minutes. We do talk about and do a one mean Z test in Stat 1401. So again, if you've had that course recently, that may sound familiar. We also talk about the one mean T test in Stat 1401. For a one mean T test, again, you have quantitative data. That's numbers. Your sample size is less than 30. The population standard deviation is not known or given. And this test is related to a distribution called the student's T distribution, which again we talked about last week when we talked about confidence intervals. For the one mean T test, you need the population mean, which again is mu, and that is the value that's in the hypothesis. The sample standard deviation, which is S, is given. The sample mean, X bar, is given. The sample size, N, is given. And again, you have to know the level of significance, which is alpha. Now, I'm going to add one in here. I'm not going to put in all the details, but just so you'll know, we're also going to do two mean t-test, and there's actually two cut types. We do the independent test, and we do the paired or the dependent. And when we get to those, we'll talk about them more in detail. That is new, okay, to this course. We do not do those in Stat 1401. So this will be new information. We will also talk about, and I'm going to break this apart, we'll also talk about chi-square. That's a new distribution. For goodness of fit for chi-square, we use it with qualitative data. Chi-square is one of the few statistical analyses that can be used with qualitative data. Remember, qualitative data is words or phrases. And so we definitely want to look at how to analyze qualitative data. We do talk about chi-square goodness of fit in Stat 1401. We will also talk about, in this course, we will also talk about chi-square test of independence and test of association. Okay, those two are new. Okay, that's a new topic. So things that you haven't seen before. We will talk about analysis of variance, or the abbreviation is ANOVA. It's kind of a combination deal because with it, we talk about quantitative data that's sorted by a qualitative categorical variable, and you have 3 or more categories. We do talk about ANOVA in Stat 1401. So again, that may sound familiar if you've had statistics recently. And then one of the last ones we talk about is correlation. With correlation, we consider what's called bivariate quantitative data. Correlation is one of the first glimpses we have into using more than one variable at a time. Correlation gets us into 2 variables at a time. There are some additional tests. All of these that I've listed here are what we call parametric tests. We will also talk about, just as a side note, there are some non-parametric tests that we will consider as well. Okay. And again, as we get to those, I'll introduce them to you because the idea of non-parametric test will be a new topic. So I'm trying to give you a heads up. Some of the content in modules 3 and 4 is going to be new. You will not have seen or maybe even heard about it previously. Most of the content that you've had to date has been material that you were previously exposed to in Stat 1401. But as we get into modules 3 and 4, there's going to be more content that you haven't seen before. And again, we'll revisit all of these different tests as we begin thinking about which test should we do. And I will tell you that that's one of the things you're going to have to be able to do on the final exam is if I give you a scenario, you're going to have to decide for yourself whether you need to do a 1 mean Z, a 1 mean T, a 2 mean. I just thought of a third one, another one that we do. We do a 1 proportion Z test and a 2 proportion Z test. And again, both of those are also new. Okay, so the list, as you can see, kind of keeps growing. They're not necessarily hard. Once you get the process down, we only have to make minor changes as we look at a new test. Again, one of the decisions you'll have to be able to make on the final exam is which test am I going to do? And we'll talk about that as we go throughout the rest of this content throughout the semester. All right, so after we've decided which tests we're going to do, we've already identified the information that we need, okay, because that was really step 2. Then we move on to step 4, and we're going to use app.minitab.com, and we're going to calculate and record. Okay, guys, record in this context means to write it down. You cannot, you may not simply copy the Minitab output results. You have to write it with your little pen or your little pencil. That's one of the biggest things that students do not do, especially on their mini projects. And it clearly asks you to record. Record means to write it down. Okay, so you will record the test statistic and corresponding p-value. Now, I need to talk about p-value, and then I got to come back in a minute and talk about level of significance because the two, they're not related to each other, but we use them both to make our decision. Okay, think about this step. This step is like gathering the evidence and getting ready to present it in the court case. Okay, the test statistic and the p-value are your evidence. Okay, a p-value, let me change colors. A p-value is a probability value. Kind of makes sense because probability starts with P. Remember, that probability, all probabilities are between 0 and 1, meaning that your p-value will never be negative, and it's never greater than 1. We like to say, oh man, he gave 110%. Statistically, you cannot give more than 100%. Okay, so a p-value is a probability value. It is the probability of getting, of getting the same test statistic over and over and over again if the null hypothesis is true. Remember, we assumed at the beginning that the null hypothesis is true. So if we have assumed it to be true, the p-value is the probability that I would get that same test statistic for any sample that I select. Basically, and that's kind of the explanation that I have there. If you keep reading, it said results from another random sample will be as extreme, extreme, or more extreme than the results in the given sample. Okay, the key thing to remember here, two things. One, you got to write it down. Two is the p-value will never be negative and it will never be greater than 1. It should be a value between 0 and 1, and it's usually expressed as a decimal. Okay, it's usually expressed as a decimal. And again, if you're thinking about this in terms of the court case, this is the evidence. Once the jury has heard all of the evidence, then they go out to deliberate. Okay? And they have to ultimately make a decision of guilty or not guilty. With hypothesis testing, we have to make a decision to reject the null hypothesis or fail to reject the null hypothesis by comparing the p-value to the level of significance. Guys, those words are important. Notice the options are to reject the null or fail to reject the null. Let me go over to a piece of paper and try to help you maybe see this again in the context of a court case. When we make our decision, when we are conducting a hypothesis test, we have two options. We can reject the null or we fail to reject the null. Remember, we've assumed at the beginning that the null is true. Just like in a court case, we assume the person is innocent until proven guilty. So if our assumption is that the person is innocent and we reject the null, rejecting the null is like the jury coming back to say that the person is guilty. This is guilty because we assumed they were innocent. We've rejected the idea that they are innocent based on the evidence, which means we conclude they are guilty. If we come back based on the evidence and we fail to reject the null, and again, in the court case, we've assumed they are innocent, we come back and say they're not guilty. Now, I don't know if you've ever thought about this, but notice we didn't say, let me write it this way. We did not say the person was innocent. See, in a court case, we don't come back and say guilty or innocent. We come back and say guilty or not guilty. Not guilty means we didn't have enough evidence, or the evidence did not convince us that they did the crime. But if we were able to gather more evidence or had different evidence, we could have come to a different conclusion. So even in a court case, we never really come right out and say that a person is innocent. We just say they're not guilty based on the evidence. The evidence did not prove they were guilty. They still could have done it, but we don't have enough evidence to prove it. That is also why you use these words. Fail to reject. Never, ever say that you accept the null hypothesis. That crawls Miss Ralston's skin and is totally incorrect to say. Your options are reject the null and fail to reject the null. Guilty or not guilty. Now, how do we decide? What is our evidence? Based on the evidence that we show, how do we make that decision? You know, in court, the jury's going to talk about it and all that kind of stuff. For us, we compare the p-value that is unique to the test statistic to the level of significance. And I'm going to talk about level of significance in a minute. Let me give you these guidelines. Here are the guidelines. These guidelines are the same every time, all the time, regardless of what type of hypothesis test you are doing. These guidelines will not ever change. So here's the rule. If the p-value is less than or equal to the level of significance, then you reject the null hypothesis. In symbols, we write P is less than or equal to alpha. We reject the null. If, on the other hand, the p-value is greater than the level of significance, then you fail to reject the null hypothesis. And here are your symbols. If P is greater than alpha, you fail to reject the null. Now, let's talk about this idea of what is this level of significance that I keep talking about. Okay, so I'm going back over to my piece of paper. Last week, we talked about confidence level. Confidence level basically is the probability of success, or if you want to think about it, it's the probability that you're correct. And we said typically it's stated as a percentage. The most popular were 90%, 95%, and 99%. They're usually stated as a percentage. Well, if there is a probability that I'm correct, I hope you realize there's also the probability that I'm wrong. The probability that I'm wrong is the significance level, or the level of significance. So this idea of the significance level is the probability of failure. It's the chance that I'm wrong or incorrect. It is usually stated as a decimal. I hope it also makes sense that the confidence level plus the significance level have to total to 1, because I'm either going to be right or wrong. And so together, those two probabilities would total to 1. So if my confidence level is 90%, my significance level would be 10%, which we would write as a decimal, which is 0.10. If my confidence level is 95%, there's a 5% chance that I'm wrong. As a decimal, that is 0.05. If my confidence level is 99%, my significance level is 1%, or 0.01. Now again, technically, because the significance level is a probability, it could actually be any value between 0 and 1. Again, 10%, 5%, or 1%, 0.1, 0.05, 0.01 are probably the three most popular, are the ones that are used the most often. If for some reason your question or your problem doesn't give you a significance level, we always default to 0.05. Okay. If a significance level is not given, we default to 0.05. I think I probably did mention that last week. Okay. So we make our decision. This is our decision. This is like where the jury goes out and deliberates. Okay. This is the deliberation. And again, rejecting the null is like saying they're guilty. Failing to reject the null is saying they are not guilty. Okay. Then it says write. The last step is to write a final conclusion in terms of the true hypothesis, including the level of significance. Your conclusion should always include your level of significance or your level of confidence, whichever way. I usually do level of significance. And most texts would tell you to write your conclusion in terms of the null hypothesis, but I've found it makes more sense to students if I say in terms of the true hypothesis, whichever one you prove to be correct or whichever one you fail to reject, or if you fail to reject, whichever one you find to be true. Okay, so there are the steps. Let me kind of highlight, go back through and hit the high points here. Step one, really you got to start, in our case, by reading the scenario. In the scenario, you will be able to identify the hypothesis. You should be able to. You're then going to state the two opposing hypotheses. You're going to identify all of the information that's given in the problem, which can help you determine which test you're going to do. Once you know which test to do, you basically do it using Minitab. That's your evidence. Then you make a decision by comparing the p-value to the level of significance, making the decision, and then you got to basically report it back to the judge. Now, I haven't done any examples yet. Hopefully that some of that sounds familiar to you. If it's been a while since you had Elementary Statistics 1, you may not remember all of that. Questions, comments, or concerns before I introduce parametric and non-parametric?
No, ma'am.
Okay, I'm going to use the PowerPoint that's in D2L, and I'll remind you where it is. So we are currently beginning Module 3. And in the first lesson, it is hypotheses, p-values, and normality. The fill-in-the-blank notes were there. I have a PowerPoint for parametric versus non-parametric. And then we'll talk about normality next week, and I have the data sets we need for doing that. So I'm using the PowerPoint for parametric versus non-parametric. And if you are one of those that likes to use the textbook, okay, this information about parametric and non-parametric is not in the free textbook that is associated with this course. I've provided the link to the blog, actually, where I found this information and summarized it for you. So parametric and non-parametric test. In Stat 1401, elementary statistics, our focus is on parametric test. Okay, we don't necessarily call them that in the course, but they are parametric. With a parametric test, we typically, more times than not, are dealing with quantitative data. meaning we have numbers. And again, I've mentioned, I think, early on that there are a lot more analyses that we can do with quantitative data, with numbers, than with words and categories. So parametric uses quantitative data. Oftentimes with a non-parametric test, with a parametric test, we assume that we have a normal distribution, that our variable, whether that's age or height or weight, blood pressure rate, whatever it might be, is or has a normal distribution. Remember the normal distribution, we've talked about it several times, but you have basically the horizontal axis. It is a smooth, continuous curve that is bell-shaped and symmetric about the mean. And so we assume that we kind of have that bell-shaped, symmetric distribution. We also assume that there are no outliers within the data set. We assume we have equal variances or equal standard deviations, if you will, that the amount that the data varies is the same from data set to data set. Parametric test, we focus on comparing the means of the data. We do a 1 mean z-test, or a 1 mean t-test, or a 2 mean t-test. We focus on the means. And we can do that again because we have no outliers. With a parametric test, we prefer to have a large sample. And just in case you don't remember, the magic number in statistics for being considered large is 30 or more. Okay. I know that doesn't sound like a whole lot, but that is the general rule of thumb, is a large sample is considered 30 or more. Ideally, we'd like to have 5% of the population. So, for example, if you have 1,000 people or 1,000 items in your population in the big picture, ideally we'd like to have 5% of that. So we'd like to have, I believe that's 50. Let me double check my math there real quick. 5% of 1,000 is 50. So we'd like to have at least 50 in our sample. One of the benefits of a parametric test is that it has what we call more statistical power, meaning the test is more likely to detect significant differences when they truly exist, meaning the test is going to be more accurate. Okay, so it has more power. And again, our focus in Stat 1401 is on pretty much those parametric tests, where again, we're assuming we have a normal distribution without any outliers, and we typically have large samples. Non-parametric it can be quantitative data. It can also be qualitative data that is ranked or is outright qualitative data. So non-parametric allows me to do some analysis on qualitative data. I can do ranked quantitative data where I've got something in a specific order. Non-parametric test, we do not assume that we have a normal distribution. And many times if I'm using a non-parametric test, it is probably a skewed distribution. It's either skewed to the left or skewed to the right. Non-parametric tests are also sometimes called distribution-free, meaning we're not making assumptions about the distribution. We're not assuming it's normal. We're not assuming anything. You can have outliers with a non-parametric test. We don't have to know the variance, or we could have unequal variances, variances that are different from data set to data set, or we may not know them at all. One of the big differences between parametric and non-parametric is that non-parametric, we test the medians. We use the medians because we have outliers present. Remember, with outliers, they affect the calculation of the mean, because the mean uses all of the data, including the outliers. Whereas the median is simply the location of the value in the middle. I'm not really calculating anything, and so it's not affected by those outliers. So if you have a data set, even if it's normally distributed and you have a lot of outliers, you may very well want to do a non-parametric test. Non-parametric also allow for a small sample. Again, a small sample, the way it's defined statistically, would be anything less than 30. But the non-parametric test has less power. It may not be as accurate as a parametric test. So if you can do a parametric test, if you can make the assumptions that it's normal and you have no outliers and that you have equal variances, then you want to do a parametric test. But if you can't make those assumptions, or you do have a lot of outliers, then use a non-parametric. Some of the ones we're going to talk about, is deciding which test to do and how to choose. Again, think about what kind of data you have. Does the mean accurately represent the center of the distribution, meaning that you have no outliers? Do you have a large sample, and is it approximately normal? Do you have quantitative or qualitative data? If you have qualitative, you have to resort to non-parametric. If you have those outliers present, the median may be your better option. It may more accurately represent the center of the distribution. If you have a small sample or an unknown or non-normal distribution, I kind of had already gone through that. Our focus in this course, the parametric ones that we're going to talk about that are new, that we haven't talked about in Stat 1401, are the two-sample t-test, the two-sample paired t-test, the one-way analysis of variance, and then the Pearson correlation coefficient, which is related to linear regression. The comparable, for every parametric, it has a comparable non-parametric. So the comparable non-parametrics are Mann-Whitney, Wilcoxon, Kruskal-Wallis, Spearman-Rank. We're also going to consider a couple of what we call post hoc tests. Post hoc means after you've got your initial results, you go kind of one step, maybe two steps further. And those are for a parametric test. We use what's called Cohen's D and also what's called 2K's test. And so we're going to look at a couple of those in addition to or with the appropriate parametric test. So that's what's kind of coming down the turnpike. Okay, we're going to be focused on parametric test and the comparable non-parametric. And for some of the parametric, we will also look at the post hoc. Kind of that extra step is extra analysis. Okay, so that's what's coming down the turnpike in the next few weeks and throughout modules 3 and 4. So do you have questions?
I don't.
All right. I do not really want, the next topic is a topic called normality, but I really don't want to get much further into this lesson because I don't want too much to cloud your mind as you are completing mini project 2 and also preparing yourself for the midterm exam. I think at least one other individual came in, maybe 2, came in after I started. But do you have, if you came in late, do you have questions related to the midterm or to the review sheet that I posted in the announcements that I can try to address before we adjourn? We're going to adjourn a little bit early tonight because I don't want to get too far out of whack. Annie, I think you came in a little bit late, and Kaylee, you may have too.
I have to look over everything. If I have any questions, I'll reach out. But as of right now, I do not. My stepdad's been helping me.
Okay. Yeah, he's had the course.
hmm
Annie, do you have questions? Deidre, did you or Thays think of any questions you may have?
No, I don't have any.
Okay, so you need to complete, if you haven't, you need to do mini project 2, which covers confidence intervals. And then I would really encourage you to work through, at least look over that review sheet and the answer key. I will post the study guide that we looked at a little bit earlier that has kind of the suggestions for things to put on your cheat sheet. Okay, I'll post that so that you can make notes of those things. Okay. Any other questions? And if you're offended that we're finishing up early tonight, we can hang out for the next 35 minutes together. If not, I am finished for the evening, and I will see you next Thursday, and we'll pick up this discussion of hypothesis testing with normality.
Thank you very much.
You're very welcome.
Thank you.
You're welcome.
Thank you very much.
You're welcome.